this is Ms. Piekarski, and in this video I'm doing the quadratic test review. Specifically on this test, we're going to be finding your solutions to quadratic equations. All right, let's go ahead and get started. In the first question, we have 16x squared minus 1. Hopefully most of you recognize that both the 16 and the 1 are perfect squares, so we can rewrite the 16 as 4 squared, and we can rewrite 1 as 1 squared. And then we have, because we're subtracting here, we have a difference of squares. So now we can take that and factor it, and we'd have 4x minus 1 and 4x plus 1. And then we can go ahead and set both of those factors equal to 0, so we can solve for our x value. And when we are solving for x, we're going to add 1 to both sides for this equation. And over here, we're going to subtract 1 from both sides. Okay, so we end up over here with 4x plus 1. And over here, we end up with 4x minus 1. We have to get rid of the 4 on both sides, so we're going to divide both factors by 4 to get x by itself. And then we'll end up with our solutions as x is equal to 1/4 and negative 1/4. All right, moving on to problem number 2. This one, notice that the equation is not equal to 0. So we need to move this 5 over to get it to equal 0. And to do that, we've got to subtract 5 from both sides. So when we subtract 5 from both sides, we get 3x squared minus 2x minus 5 is equal to 0. And then we need to go ahead and factor this by grouping. And so what we need is we need two numbers that add together to get negative 2 and multiply together to get negative 15. So the reason why we're doing negative 15 is because of your leading coefficient here. This 3 here tells us that, so the 3 times negative 5 gives us negative 15. But we still want the two numbers to add together to get negative 2. Now, because we want a negative here, this means one of our factors has to be equal or has to be negative. Okay, and so the two factors, if we do 3 times negative 5, we do get negative 15 when we multiply them together, and when we add them together, we get a negative 2. So when we are writing our 4 terms, we get 3x squared plus 3x minus 5x minus 5 is equal to 0. Now we can go ahead and separate those 4 terms into 2 different groups. And we're going to factor out our greatest common factor. So for these 2 groups, we will have 3x, and then we'll multiply by x plus 1. And over here, we can factor out a negative 5. And so when we factor out negative 5, we got x plus 1. All right. So now, both of these terms, we can factor out an x plus 1. And what we have left is 3x minus 5. So now we're going to take our 2 factors, set them equal to 0, and we get this. Now we have to solve for x. Over here, we just get x is equal to negative 1 by subtracting 1 from both sides. Over here on this factor, it's going to be a little bit more complex. We have to add 5 to both sides, but then we have to divide by 3. And when we do that, we get x is equal to 5 over 3. So just like problem number 1, we're going to have where we had 2 solutions. One was positive 1/4 and negative 1/4. Over here, we are also going to have 2 solutions, but this time we have one solution is negative 1. The other solution is 5 over 3. Okay, let's look at the next couple problems. This one, we're just solving using the square roots. So here we just have x squared equals 81. We can square root both sides, and we get right here. And the biggest thing to remember, anytime you take the square root, your answer is always both positive and negative. So when we do that, we end up with x is equal to both positive and negative 9. For number 4, we've got this equation here, and one thing we need to remember is that we want to get our variable by itself. We want to isolate that, so we want to move this -7 and the -4 over to the right. We're first going to take care of the -7 by adding 7 to both sides, and when we do that, we get -4x squared is equal to 16 because 9 plus 7 is 16. Now, to get rid of the -4, we're going to divide both sides by -4. And when we do that, we get x squared is equal to -4 because 16 divided by -4 is just -4. When we square root this, remember your answer is always both positive and negative. So we have both positive and negative square rooted -4. Hopefully you guys all remember that whenever you have the square root of a negative number, then you need to have the I there. And there's our I, and then the square root of 4 is just 2. So our answer for this one is x is equal to positive and negative 2i. Moving on to problem 5, we have x squared minus 3 equals 17. Let's go ahead and move that 3 over by adding 3 to both sides, and we get x squared is equal to 20. Let's go ahead and square root it, and again our answer is both positive and negative square rooted 20. The square root of 20 is not a perfect square, so we are going to have something left under the radical, but we can reduce that -20 because the square root of 4 times the square root of 5 is equal to the square root of 20, and most of us know that the square root of 4 is 2, so our answer will become positive and -2 times the square root of 5. Let's move on to numbers 6 and 7. On this one, it says find the zeros using the quadratic formula. So on this one, everything is in the standard form. So our A value is 3, our B value is -10, and our C value is +5. So in the numerator, we're going to start off with a -10 plus or minus the square root of -10 squared minus 4 times 3 times 5. All right, now in the denominator, we're going to just have 2 times 3 because our A value is 3. Now we're going to reduce this piece by piece. So this -10 becomes a +10. And then plus or minus, -10 squared is going to be 100. The 2 times 3 gives you 6, and -4 times 3 times 5 is -60. Okay, if you want to pause this video and check in your calculator, make sure I did all the calculations correctly, you can. All right, now the next step, we need to combine the 100 minus 60. The 10 is going to stay the same, the 6 is going to stay the same, and 100 minus 60 is just 40. Now, I need to find out if I can reduce this radical. 40 is not a perfect square, so I might be able to reduce it, and I can because 4 times 10 is equal to 40. And so I have the square root of 4 times the square root of 10, so the square root of 4 is just 2. Square root of 10 cannot be reduced, so that's going to stay under the radical. Now I can reduce this fraction. 10 divided by 6 will be 5 over 3, and 2 divided by 6 is 1 over 3. So I end up with the answer of 5 plus or minus 2. Oops, that should be a 1. So 5 plus or minus the square root of 10 divided by 3. Okay, number 7. Again, we need to move this 8 and the -2x to the other side. So we're going to add 2x to both sides, and we're going to subtract by 8. When we do that, we get x squared plus 6x plus 9 is equal to 0. Now that we have the standard form, we can plug everything into the quadratic formula. Our A is 1, our B is 6, and our C is 9. So we're going to have our negative b value, so negative 6 plus or minus the square root of 6 squared minus 4 times 1, because that's our a value, times 9, because that's our c value. And then in the denominator, we will have 2 times 1. We need to go ahead and simplify everything. The negative 6 is going to stay the same. 2 times 1 is just 2. So in our denominator, we'll just have a 2. The numerator will start off with just negative 6. But under the radical, this 6 squared becomes 36. And the minus 4 times 1 times 9 also becomes 36. But it's going to be negative because of this minus right here. So now the 2 in the denominator is still going to be there. The negative 6 up front is still going to be there. But the square root of 36 minus 6 will just give us the square root of 0. And the square root of 0 is 0. So in this case, we're just going to have negative 6 divided by 2. And notice, because the plus or minus is right here, and then you're just adding or subtracting 0, we don't have to worry about the plus and minus anymore. And our answer is just going to be x is equal to negative 3. For problem 8, we have a graph right here, and we just need to look at the graph and find the solutions. Hopefully you guys remember that your solutions on your graph show up as x-intercepts. So we have an x-intercept here, we have an x-intercept here. So here we have, this is negative 1, because each of these grid lines is 1 unit. And then over here we have the x is equal to positive 2. So our solutions will be negative 1 and positive 2. Number 13, we have this equation, y is equal to 2 times x squared minus 8x. And I need to find the axis of symmetry. I need to fill out my table. I need to find my vertex, my domain and range, and I need to graph it. So first of all, to find the axis of symmetry, we need this formula. So it's going to be x is equal to negative b divided by 2a is the formula we're using for our axis of symmetry. And in this case, our a value is 2, our b value is negative 8, and our c value is 0 because we don't have a constant term here. So when we plug this into the equation, we'll have a negative out front because of this negative here. And then we'll also have a negative in the numerator because we have our b value is negative 8. And then in the denominator, we're going to have the first 2 is from here. The second 2 is your a value up here. So then we have negative 8 divided by 2 times 2. And then, but we also have this negative up here, so out front. So negative times a negative, that ends up being a positive. We end up having positive 8 divided by 4, and 8 divided by 4 is just 2. So this is going to be our axis of symmetry is just x equals 2. So we're going to start off on our table with 2 in the middle. And in this case, they only have space on their table for 3 different values. So we're going to start with 2 in the middle. We're going to subtract 1 from that, and we get 1 here, and add 1 to our 2 and get a 3 here. So now to find the y values, we are going to plug in 1, 2, and 3 into this equation up here for our x values. So for the first one, we're going to have 2 times 1 squared minus 8 times 1. Okay, 2 times 1 squared, well, 1 squared is just 1. So we're just going to have 2 times 1 there, minus 8 times 1 is just going to be negative 8, or minus 8. And then 2 times 1 is just 2, minus 8 gives us negative 6. So when x is 1, our y value is going to be negative 6. When x is 2, we plug it into the equation, and we get 2 times 2 squared. Well, 2 squared is going to be 4, so we'll have 2 times 4. And then negative 8 times 2 is just negative 16. And then when we go ahead and simplify that further, 2 times 4 is 8, minus 16 gives us negative 8. So now when x is 2, our y value is going to be negative 8. And now let's plug in the 3. Most of you already have filled this out because you know that it's symmetric. So if this is negative 8 and this is negative 6, because this is our axis of symmetry, the 3 value will give us a 6. Let's go ahead and look at it. When we plug in 3 in for our x, we multiply everything out, or square our 3, multiply the 3, 8 times 3. We end up with 18 minus 24, and 18 minus 24 is negative 6. So we get negative 6 for our, when x is 3 and when x is 1. And when x is 2, which is our axis of symmetry, then we have a negative 8. So our vertex is going to be from these values here. Our vertex, the coordinates for our vertex are going to be 2, negative 8. Now, before we get to the domain and range, let's go ahead and look at our graph. And let's see, what do I have selected? Yep, there we go. If we plot our point, let me see if I can make this screen smaller. There we go. If I plot these points, when x is 2, my y value is negative 8. So I come down here. Here's x is 2. Here's negative 8 for the y value. So our vertex is right here. When x is 1, our y value is negative 6. So here's 1. Negative 6 is right here. And then 3 and also negative 6. So 1, 2, 3. And negative 6 we have right here. And then we can go ahead and connect the dots. Okay, so this is what our graph looks like when we graph it. So, but if you recall, as this graph keeps going up, it's also going to keep spreading out on your domain. So we can say that the domain, which is all your possible x values, goes from negative infinity to positive infinity. Or we can also say that x, it includes all real numbers. And then on the range, that's all possible y values. Our lowest y value is negative 8, and our highest y value is positive infinity. So we'll say negative 8 to positive infinity. And I just realized this should be a bracket, not a parentheses. I might have to cut that out. Let me see. A bracket there and parentheses there. Sorry about that. So it should be a bracket, negative 8 to positive infinity, or we can say that y is greater than or equal to negative 8. Okay, so that's the way we can set up the range. Let's see, we've done everything here. Let's go ahead and expand this out again. There we go. All right, number 14. Same type of situation, just different formula. Again, we need to find the axis of symmetry. We need to plot our points. We need to find the vertex, the domain, and range, and we need to be able to graph our equation. All right, so axis of symmetry, formula is still the same. In this case, our A value is negative 4, our B value is positive 8, and our C value is negative 4. So we start off with negative in the numerator. We end up with 8 in the numerator, and then negative 4, or 2 times negative 4 in the denominator. Why do I have a negative 8 there? It should be a positive 8. Okay. We should have a negative 4 here. So we have a negative 8 times 2 times negative 4 is also negative 8. So we have negative 8 divided by negative 8. The reason why this is negative here is because of the negative that's out front from this standard equation for the axis of symmetry. So negative 8 divided by negative 8 gives us positive 1. So now on our table, we're going to have the 1 in the center, 0 here, and a 2 here. So we're plugging in 0, 1, and 2 into our x values. So in the first case, we have negative 4 times 0 squared plus 8 times 0 minus 4. Well, this ends up being just 0 because we're multiplying by 0. And this also becomes 0 because we're multiplying by 0. So we're just left with a negative 4. So when x is 0, our y value is negative 4. When x is 1, Let's go ahead and take this step by step, semi-step by step. There we go. When x is 1, we plug it all in. Here we've got -4 times 1 squared plus 8 times 1 minus 4. 1 squared is just 1, so we have -4 times 1, which is just -4. 8 times 1 is just plus 8, and then we have a -4. So now we have -4 plus 8 minus 4, which ends up with 0. So when when x is 1, our y is 0. Why do I have a -16 there? It should be 0. Sorry. Let me make sure I put a -4 there. Yep, I did put a -4 right there. I might as well uncover it since I already spilled the beans, but most of you already realized it was -4 here because we have a -4 here. Let's check our work and make sure we get -4. So -4 times 2 squared plus 8 times 2 minus 4. We get -4 times 4, which gives us 16 here, or -16, excuse me. 8 times 2 gives us 16 minus 4. We have 16 minus 4 is 12, -16 plus 12 gives us -4. So when x is 2, we also get a -4. Our vertex is from our center coordinates, the 1 and 0. So, I did leave it at -16. I don't know why I did that. So our vertex is at 1, 0. And our two other points are 0, -4, and 2, -4. Let's make this not that small. There we go. I can make it a little bit bigger. All right. So let me uncover the graph. This is what our graph is going to end up looking like. When x is 1, we're at 0, so our vertex is right here. When x is 0, our y is -4, which we see right here. It almost looks like it's at -3, but it's actually at -4. If you look closely, it's at -4. And when x is 2, our y value is also -4. So this time where our graph is going down, we're going to end up with a maximum, and then it's going down again. Again, as it keeps going down, the graph is going to keep spreading out and get wider and wider. So our domain, which is all possible x values, is from -infinity to +infinity. Or we can say that x includes all real numbers. On our range, our lowest number is -infinity. So we would do -infinity. Our highest number is a y value of 0. So we will say it goes from -infinity to 0. Notice I got the brackets there because we do land on 0. We're going to have brackets. And then we could also write that as y is less than or equal to 0. And the reason why it's less than or equal to 0 is because it's going down instead of going up. Okay, I think this is the last two problems. For number 15, we're just asked to solve, find the zeros of the following quadratics using any method we choose. So we just need to solve for x. With this one, the easiest thing to do is divide both sides by 16. So when we do that, we're just dividing both sides by 16. We end up with x squared is equal to 1 over 4, because 4 divided by 16 reduces to 1/4. We do want to square root that. Again, hopefully you guys all remember that the answer is both positive or negative. And then we'll have positive or negative the square root of 1 over 4. Well, the square root of 1 is just 1, and the square root of 4 is 2. So our answer for this one is x is equal to positive or negative 1/2. And then over here for the part B, again, notice we have this equation is not equal to 0, so I need to move this negative x squared over. So I'm going to do the opposite. I'm going to add x squared to both sides, and then we would have 6x squared minus 3x is equal to 0. With this one, the easiest thing would be to find our greatest common factor. Both of these terms can be divided by 3. They can also be divided by x. So my greatest common factor would be 3x. And when I divide 6x squared by 3x, I'm just left with 2x. And negative 3x divided by 3x is just going to be negative 1. Now I can set both of those factors equal to 0. And I did it again. I should have had a 3 here instead of a 2. Yep, there we go. Should have a 3 here. So 3x is equal to 0. And then I'm going to do 2x minus 1 is equal to 0. So I'm just setting both factors equal to 0. Now the cool thing about this is if I divide both sides by 3, I'm just left with an x. And 0 divided by 3 is just going to be 0. So x, from this factor, I get the solution x is equal to 0. Over here, I am going to have to add 1 to both sides of the equation. And then once I do that, I get 2x is equal to 1. And then, so now I want to divide both sides by 2, and I'll get x is equal to 1/2. All right, so those are the types of questions we'll have on the review. Please watch this several times. Make sure you understand how to find all of your solutions, and good luck on the test.